Okay. Okay, yeah, it's ready, right? It's recording. I'm sorry, what's the name of him?
James.
Oh, James.
Is it recording? Yeah.
Okay, it's good now? Okay. So welcome everyone, good morning. Today we have a special lesson. It's a kind of a different one from the previous ones. And today we're getting an overview on Foundry. That's the main point today. But I want to start with what we've been doing up until now. The speedrun on Ethereum, the theoretic lessons from you, everything has been just testing on local. And the last session, it was the first time that we deployed our contract to a testnet, right? And this was done with hard hat commands. So hard hat is a framework to build, test, and deploy commands as well. And they compete with Foundry, and in that sense that they do almost the same things, but they have different features. So hard hat is used with TypeScript, JavaScript. The Foundry one is used with Solidity. So it depends on which one you like the most, and on which of the features of hard hat or Foundry you like the most. But for today, we're going to focus on Foundry since it is the one that we have more expertise on. Yeah, so what's Foundry? Foundry is a powerful and comprehensive tool for building, testing, and deploying your smart contracts. It's kind of popular nowadays, and if you're serious about your smart contract development, you should use Foundry for your smart contract projects. Okay, today I'm co-hosting with you. You were here today, so nice. And we're going to start right off the bat with the installation part. The installation process is fairly simple. You just have to copy this command, and it's going to download a script from Paradigm, and it's going to try to install the Foundry package. So I don't know if we're going to try to do it now, or just you can try it on your PC, right?
So it's about the content and the different part during the slide.
Okay, yeah.
Find some. For this part, I have a slide comparing the about the Foundry.
Oh no, I thought that we were gonna run the script for installing.
Installation.
Yes.
On your computer or on mine?
On your computer because it's already.
Oh yes. So about the.
Well, I guess it's not necessary, right? just.
Yes. In my computer, I have the Foundry installed first, but maybe you can try and kind of it will upload or do, and we can do the
So yeah, so when you run the script, you just download the installation script, and then you gotta run Foundry app to install the actual Foundry tool. Yes.
And it will upload, and maybe I already have it installed, so it will updating and do some others.
Yes, Foundry app.
And Foundry app down.
So Foundry app is for installing the Foundry toolkit, but it's also for updating the Foundry to other versions.
Yes, you can copy the comments from the Foundry book. Here is the installation.
Oh yeah.
The getting started part, and you can just copy it for her and have all the Foundry app comments, and you can refer to the documents. And also you can, if you have Rust installed, you can also build
from source.
But it's not necessarily we need it. And this is and also you can use Docker if you don't want to install too many things on your machines, and you can use Docker. And about the project management?
Yes. So yeah, to start building your projects with Foundry, you can just use the forge init command, and this forge init command has a lot of params, a lot of configuration, but the default config will create like an empty file, an empty project with already a smart contract on it, and a test and a script, so that you can check out how a test or a script is built. You can just try the init command. Yeah.
And you can put maybe some Foundry demo.
Yeah, you can put a name on the project.
Demo and okay, not really. Kind of like it will install some. Yes, and once installed, it has some very basic project structures and some others. It has some counter demo contracts and some tests and some maybe like the basic node modules, Foundry.toml and okay, yes. And some basic scripts like counter.so and some libs installed from the Foundry lib and kind of others. And you can also install from the package and some kind of other things. It just follow the forging init. But if you already have some smart contracts, and you can use the forging init dash force to force install it, and it will reinstall the kind of the Git modules from the Foundry-ORS and kind of other things. And for some configurations, we have maybe the kind of like maybe I can show it in my demo. Kind of like the format part, we have this one. We can have some kind of like the prettier to format our kind of the code, the tab-wise, and some kind maybe the compiler and some kind of Foundry parts. Foundry part we can also have some the source version, and we can specify the version we want to use, and we can open it as the auto detect, and we can specify the EVM version and some kind of other configurations. We can all set it in the Foundry.toml, and they are kind of very complex configurations. We can refer to the Foundry book.
Foundry book, yes.
Yes, Foundry book, and
So the Foundry.toml is like the place where you can change all of the configuration strings for Foundry. You can change the Solidity compiler. You can change the formatting ways of the files. You can change the some of the test running, also script running parameters. Yes, and you can check all of the configuration that you can change on the toml file here in the Foundry book as well.
Yes.
Section.
Section.
Yeah, configuration.
Yes. And also it has the integration with VS Code. If you're using VS Code or some other like Cursor or some kind of other IDEs based on VS Code, you can use maybe kind of the remapping, and you can use all the dependencies in your VS Code configurations, and you can set in the VS Code format, and kind of like you can the default formatter, and the kind of the use forge, and you can specify the Solidity version and kind of others. That's for your local developing and debugging, and that's very useful. And also you can use the kind of the command like forge fmt, and it will automatically format all your codes here. Mm-hmm. So it's kind of like some plugins or some extensions of VS Code can also do that for you. Mm-hmm. And yes.
And for the other one, for the contract deployment, we already have some demo that we use the Foundry init, and we have some demo. Okay, yes, we have some demo. Correct? Not this demo. No, not Foundry demo. Yes. It's the demo in the counter here, and in the maybe the last class on maybe this Monday or this Tuesday, I have the ERC20 ones, and we can deploy it on our local device. We deploy the contract using the remix, but today we can use it we can deploy it and debugging it in our local machine, and kind of like this. Yeah, maybe I can open remix and do some comparison. And yes.
If you remember the last time that you gave a lesson, it's he used remix to deploy all these contracts. So for now, he's gonna show how to deploy this not using remix but using the Foundry toolkit. So now he's gonna do like a little comparison between using remix or Foundry.
Yeah. For remix, we have some. Yes, I don't have the local ones. Yes,
it's not there.
Kind of strange. When in remix, we have the file explorer, and we have some maybe the Solidity compiler and some deploy. And if we want to compile the code in our Foundry project, and we can just use the Foundry build, and it will compile all the files that we already write in our SRC, and we have the ERC20X, ERC20Y, all kind of other smart contracts. We use Foundry build to compile it, and all the compiled it will be artifacts. There will be the ABIs and the bytecode, kind of the others. Maybe this one we have some deploy related, yes, and the output, and we have this one, maybe the ERC20X or Ys, and we have this one. It's our ABI. It's in the out directory, and we can copy the ABI for the front end to use it. It's the same like maybe have some contracts, and I compiled here, and I can copy it here. But in the Foundry project, we can copy it just maybe using the JSON format, and we can just copy the ABIs from the output. And about the deploy part, we have two methods, maybe two functions to deploy our smart contracts. The first one is we can also forge create. We have the forge create command, so we can just use the forge create with some arguments to deploy our smart contracts just using the command line, and also we can write our own script to do the deployments. And I will show the this one. And firstly, we need to the remix will have some kind of the local environment. It's embedded with a remix VM, and we can just use it. But when in our local machine, we don't have some kind of blockchain, so we need to use the Foundry building command called anvil. Okay. Yes. Okay.
Yeah. So like you said, in Remix you have online blockchain per se, let's say like that. But in your local machine you don't have a blockchain, so you have to start a node on your local machine, and you can do this with Foundry with the anvil command. This is already installed by default when you install Foundry with Foundry Up, so you can use the anvil and some options to run a local node, a local blockchain node. Yes, you can. Can you just go? Yes.
Maybe okay.
So with the ambi command, if you execute it, it's gonna start a local node, and it's gonna give you already like 20 accounts for you to test with, I think 10,000 or 100,000 ETH that you can spend, and you have all these accounts on your local machine. You have all these accounts with all this ETH, and you have the private keys so that you can import and deploy contracts with these private keys. I don't know, import them in MetaMask and use them in MetaMask. So everything is going to be done locally in this local chain. And if you stop the local chain and you start again, all your contracts will be gone. You will have to redeploy your contracts again. And yes, but this is very useful for when you wanna see how much gas your contracts deployments are using, how much gas your transactions are using, because everything will be logged in this local blockchain.
So once we run the NVO command, so we have a local blockchain, and if we want to deploy or create some smart contracts, we can use the RPC using this one, you can specify the port here, and in our commands, I have some commands for copy, and we have the forge create. This one, forge create one. Yes. We have the okay. We have the kind of like. You can see it here. We have the forge. Oh, okay. Yeah. Yes. Yes. Yeah. This one.
Very difficult.
Yes.
Yeah.
Yes. Okay. We have some some arguments here. Use the forge create, and the first argument we need to specify the contract file. The location of the function, the smart contract file, is in the src and the erc20y.so. So we use the forge create src erc20.so, but we use the comma, and we use the invisible garden token y, and it's from here. We need to specify which contracts we need to deploy, because even mostly we will write one contract in one file, but you can write two, yes, and kind of like you can specify two smart contracts in one file, so you need to specify it. And for this one, and the RPC URL, the RPC URL is the maybe if you want to deploy on the local machine, and you will specify this RPC, and if you want to deploy on some maybe Ethereum, Sepolia, or some other testnet, you can specify others. And the provide key, and is from the auto-generated one. We use the first one, and also you can use others. And each of these accounts have 10,000 is from the contract, so it's enough for us to test. And we specify the private key. And another we need to do, because our smart contracts need a constructor, we need to initiate some initial supply when we deploy our smart contracts. So we should using the constructor args, and specify the number we want this token to have the initial supply. So we need to specify these args, and when we write our when we run our forge create command, and we can run it for test. Kind of like because I run it before, so it will not compile. If you are running this first time, it will compile like the forge build. The forge build, it will run first, so kind of like this. And we can see it in our the command line, or in the logs of our local NVO chain. It has some transaction that's the contract created, and the gas used, and some block number, kind of other contracts, and we deploy it twice, so it has the two transactions. Kind of like this, we can see it here, and it's the same as we see it kind of like here, so in the remix. And we have another method because we using Foundry Create, we need to pass some kind of the arguments in the command line, and it's not safe, or kind of like or if we yes we maybe we omit or we've got some args, it will wrong. So kind of like as we will also write our own deploy scripts here, kind of like. Do we need to introduce the script first?
Yes. So like Hard Hat and like on the Remix IDE, you can also do some scripts to test your smart contract functions or a flow of transactions that you wanna test. You can build a script for this. And the nice thing about Foundry is that your scripts are built in Solidity, so you don't have to learn another language, or you don't have to use JavaScript or TypeScript for this. It's in Solidity. So the first thing for a script that you need to do is just import a script utility from Forge STD, and then you're gonna start your transactions with the bn start broadcast, and then you're gonna stop your transactions or finish your test with the stop broadcast command. For the execution part, you can specify some options for the network. Broadcasting transactions or providing private keys, of course. We can do an example right now with a script.
Yes. When we using the script, and I will see. Oh yes, I write one very simple script here, and we have the because it's writing in Solidity, so it's very the same as the source contract. So we just import the script from the Forge STD, and we export our smart contracts we write before, so we could use it in our later deployments. And kind of the deploy is also a smart contract, and it will inherit from the script, and it has some method called run. We can define the run because it will when we execute the script, it will execute the run method here, and we can kind of define that we need a provide key to deploy our smart contract, so we can have it from the env or kind of from the from the comments we here, and we have the start broadcast. Only the code between the start broadcast and the VM.stop broadcast will execute on the chain. Other place maybe we want some console, but the console are not related to some on-chain actions. We could put it after the stop broadcast. We only put some logics that will execute on our blockchain. Will be between these two comments here, and we can define the initial supply here, and we can just use the new keywords to deploy our smart contracts. It's very easy, just like that we writing some smart contracts here. So you don't need to maybe learn some TypeScript or some kind of other programming languages. And about the comment here, kind of the same, or kind of the here that we use the Forge script command, and we need to specify the script location here, and it's deploy dot here is a deploy dot s dot so, and we need to specify the deploy contract here, and we need to specify the chain ID and kind of like the RPC URL or the private key here. We can execute here. Yes, we run the script here, and it has some. We have the block number of 3, and we have a new transaction here, and the contract created here, and it's kind of the same as the Forge create, but you can do more. Maybe maybe you want to deploy the same smart contract to several blockchains and or to some kind of others or some very complex initialization like maybe the initial supply or some kind of other argument you want to set it in the code or not in the command line, you can use the scripts.
I will show an example of a big one.
Oh, yes. Yes, one of my smart contract here, we have the very complex deploy script here. We have the deploy config here. We have some kind of the console, kind of the constructor, and deploy one. We can deploy lots of kind of the smart contracts here. We have the proxy, we have the upgradable, some kind of initialization. We can divide it into different methods here. And we can initialize the social part. We do some, maybe we deploy the social proxy first and do some other very complex things. And kind of like very, very useful for some, maybe if you in the production environment, you want to deploy your smart contracts, or you want to deploy several smart contracts one by one. Maybe if one is finished and the contract address of the first smart contract should be the args of the next, so you can use the script here, and kind of like this. Okay, yeah, and for the kind of the scripts here, and some and next we do the test or do some.
Yes.
Yes, we have some nodes here, scripts here, and maybe for the testing part.
Oh, no, you can do the testing.
Oh.
I thought I was gonna do this once.
Okay, yes.
Yes, I'm really covered. So.
Yes, maybe I can larger kind of the. Oh, okay. Zoom and kind of the zooming part. Okay. This part.
We cover this.
Yes, VS Code part, format part, local chain part. The thread is not necessary to mention, and the forge scripts here. Maybe it's kind of the cast here, comment here, and we can cover the testing part.
No, I don't want to cover the testing part.
Oh, yes.
Can you cover the testing part?
Oh, yes, I will go to the testing part.
Yes,
Yeah.
I thought I was going to cover this.
Okay.
But yes, okay. Oh yeah, so for last section for the testing, you can also use the cast command, like you see it here. The cast command is useful for when you want to send transactions or specific transactions to contracts from the command line. You can just use cast send and then specify like an address for a contract and then specify the method for this contract and the arguments that they have to receive. And then here you can specify the arguments one by one. And then you need to specify a URL, of course, for a chain, and then a private key. So this is for sending transactions that cost money, right? That cost gas. But if you just want to have or consult a contract or get a result from a contract from a variable, you can just use the cast call. This is for calls that do not use gas, of course, and just retrieve values. In this case, let's say that in this contract XXS we have a retrieve variable. We can just get the value from retrieve with this cast call function. And this one I have no idea.
Oh yeah, yes, and we can have some helper functions or some helper commands here, and about the cast, and we can refer to the forge book. About the cast part, we have some comments here. We can use the maybe cast receive, cast send, cast call, cast RPC, TX run, or some kind of gas price or some others. For example, we can execute some comments here.
Yeah,
yes. Okay. Yes. a little bit smaller. Yes, and maybe we want to just set a hello world to the using the cent, and we can because we have our MVO blockchain local blockchain run on, so we can have another comment here. We just use the cast send, and we set our private key here, and we have the from the UTF-8, and we just maybe broadcast some messages on the blockchain, and we can have this kind of the transactions execute, and it have the transaction hash and the gas used and all kind of others. And we can also use some kind of like the cast maybe we can try the cast balance here, kind of like the balance, and maybe we can use it for the from and kind oh no yes it has some maybe I can run it here. Oh no, not this one. Cast balance and kind of like this one. Yes. We have some kind of the balance here, and also we can use some other maybe we want to query about once we always maybe query some maybe block informations or some transaction information. So we can also use the cast here. And the cast you can also specify the RPC, so you can interact with the real blockchain or some testnets here. And kind of like this, the cast is very useful for us to do some simple debugging or some maybe you want to execute some very simple transactions. You don't need to write the whole scripts here, also or some kind of the deploy or some kind of the coin scripts here. So you can use the cast. And yes, and the first build is already covered here, and okay. And that will cover the testing part, yes. I need to hear? Okay. Kind of actually,
I can do like a little overview at the end.
Oh, yes.
So if it's not clear, I just show the 4 or 5 commands, and then it's clear.
Yeah, yes.
Show a project.
Yes.
Yes.
Yes. Okay. And for one of the very useful things I think about Forge is that we can write some tests using the Solidity, and we can testing maybe some kind of the method, or we can simulate some kind of the on-chain actions in the using kind of these helper methods like the vm.prank, vm.deal, or kind of like vm.assume, or kind of other methods. We can simulate some kind of the on-chain adjust actions here. And also for the demo part, I already showed some kind of the tests in our last lessons about the ERC20, and a very simple test here is about that we also write it using the Solidity, and we have the specify the version, and we need to input the tests from the Forge standard library, and we have to input our smart contracts here, and maybe we want to input some kind of the interface or from other smart contracts, OpenZeppelin, or some kind of other libraries. And the test is also a smart contract, and it's the same with our contract or our scripts. It's the same. And the ERC20 test, and we have some variables that we defined in our smart contract here, and the invisible garden token wise input from our smart contract. And we can define some adjust here. We can define the alias as as an address, and we can define another one, and we can define some variables like the initial supply using the just the variable definition in the Solidity, and we define the events here. And one of the first thing we need to write is the setup function. Set method is the when we run. It's kind of like the script here. When you run the script, it will run the run method. But when you test your smart contracts, it will run all the setup method, all the logics in the setup methods here, and you need to do some deployments. You need to do some kind of the initialization, or some kind of, if you want to do more logics, maybe you simulate some existing transactions, or you want to simulate one of the very specific maybe scenario of your business logics, or some kind of other logics you can define all in the setup functions. And the setup functions will be executed before the very specific tests you want to execute here. And about the kind of you can use the assert equal to compile the one that you actually get, and the one you want it to be, you expect it to be, or kind of like this. So the process of the testing is that you define a test. Maybe you want to test the transfer. We already have a ERC20 token. We want to test if the transfer method or transfer feature is working well with all our logics here, and we can define the amount we want to transfer. We want to transfer 1,000 here, and the VM prank is kind of the helper methods using in the Foundry. And when we call the prank, the next the next transaction will be executed by this pranked kind of the address. We use the VM.prank, so the next function here that is here, token.transfer, will be executed by the Alice. If we change it to kind of others, but if we want to maybe change another, we need to prank it again. It's kind of like the prank is only the very next, not maybe the every transaction be after here. And we can use another method called kind of the prank start, or kind of the others here. Okay, this is the prank, and the what's here? Okay, no, not here. Yes, the address sender here, and we use the prank, so we can specify that's who is calling, because maybe if Alice have some balance of some kind of our smart contracts, our ERC20 token, so the Alice should do the transaction first, and we can also define the expect image here. It can kind of like this. It can be the check topic, because we have in our lessons we can define the events here, and kind of like the events here. We have the event called maybe the transfer, and we can have 3 indexed events here. So if the events arguments are indexed, it's called a topic in the Solidity. And this one maybe is not indexed, it will be the data. It's kind of the differences between the indexed or not indexed one. And in the VM, we will check the first 3 because we can only have the 3 topics or 3 indexed events here, events arguments here, and we have all the other data in the last part. So we can expect emit here, and we can check maybe the first 2 to our indexed data is the from and the to, and so we can check the from and to here, and we will see that we will emit the transform events here, and when and after okay, yes, and we will do the emit our transfer here, and we have the boolean the success. It will, when we call the transfer method here, we have one return value called the boolean. If it's transferred successfully or failed, some kind of the result when after we execute our transaction. So in the boolean, so we will check the boolean part, and we can use the assert true to this successful boolean part, and we can assert the kind of the exactly, or maybe the actual number, actual amount of all the, because Alice is transfer some amount to the another account called Bob, so the balance of Alice should be deducted by the amount here, and the balance of Bob should be exactly the same as the amount that Alice has transferred to his account. It's kind of like this, and we, another things we want to mention is that we can maybe in some other smart contracts here, in our we also have some kind of the VM helper function called the assume. Assume is that we maybe we want maybe the Alice or some other account, it have some initial value, kind of like this part. And when we run the envil, each of the accounts are equipped with some balance, and if we want to also in the test, and we want to have some balance of one account here, we can use the assume method to maybe, and it can be a actual maybe exactly number amount, and it can be some kind of the random number between kind of this one. So we want to check some aging case or some kind of the testing, we can make it random, so we maybe we can have some more testing case from here, and each execution it will run, it will assume a new amount of the its balance here, and kind of like other comments here, and we have kind of the deal, and we can find it in the Foundry book. Foundry book is very helpful resources for you, so we can use that. It's also the same, very similar to the assume, but you can specify maybe the Alice and the one is, or some kind of other numbers that you want to make the Alice balance, and you can exactly get the same balance of the one U that you deal. And kind of like the Hawks is, so there are some different methods, but do the very similar kind of the features here, and the Hawks have some kind of more control to the method that you want to do using the Hawks, and if you using the setup prank, and you can have some ease, and you can do some kind of other things, and you can refer to this document here. And maybe the others you can refer to the Foundry book, and I will go back to one of our smart contracts here, and it's kind of the same logics here, and kind of like this. If you want to call some methods here, and you can just assert some equal. Okay, you can have the kind of the expect, and you can expect some emit, or you can expect some revert here, because in some case we want to test some kind of the failed case, so we can use maybe the test and with the and with the failed words, and you can expect some revert, or you can accept some kind of the it's not maybe not equal with the one, or kind of other things. So in our smart contracts, we always have some successfully called maybe success test and fail test. We can define it in the maybe kind of the same, and the best practice of is one, you have the ERC20y, and you need to have the ERC20y.t.so, so you can write some successful test and failed tests in the maybe in this kind of like this. Yes. And I think test is kind of a very complex thing, because it very depends on your kind of the business logic, your smart contract logic. So the basic syntax is not very complex, and you can I always use just prank, expect emit, and expect revert, or kind of the assume kind of others. I don't use too many maybe features of the test, but we can write some very complex smart contracts here, and maybe I can show a very demo, kind of like that. Maybe we want to test, we should initiate, and we should do transfer, and we should do some approve, and do some kind of the construct, and do some kind of the logics, and you can write, or you can simulate all your kind of the maybe several transactions in one test. So you can do some integration test, or you can test some only some simple methods, and you can do some very complex here, like this one. We have the kind of like we have assumed some variables here. We can transfer some tokens and approve some tokens, and we execute some methods, and we maybe do another transaction here, and we use another account. So kind of like this, we need to write it in all the same kind of the methods here, and you can test it with help of the Foundry book, and maybe it has some demo code, and it has some kind of maybe the Hello Foundry, or kind of others. It has some demo tests here, and you can write more logics and test all the features, all the maybe some popular features in the Foundry book about the testing, or about the scripts here. Oh, bubbles. Oh, okay, yeah. And when we here, okay, here, okay, and after we write some smart contracts here, we need to execute our smart contracts. Like we use the forge test command, and if we just run the forge test, it will run all the tests here. So no matter you have many kind of the test file here, it will run the all, and it will have more kind of like the path, and if one of them are failed, it will have some output. And you can also match some smart contracts here, and you can match the contracts of the ERC, kind of the maybe this one, and you can only run all the tests you defined in this file, and also you can, and we have a very common and also our favorite features about the test. We can use the verbose log, and maybe we can test one by one. Yes, we have the one, and we not some differences before, and kind of like we have two, and the same, and kind of like this. And if we want run it for full, and we have more kind of the cost stack and some kind of other details of our smart contract, even the test is successfully, so kind of like this. And we can have the 5V. The 5V, we can have more kind of the details about our smart contracts. And one is about the 3 one. Maybe if we have some failure, yes, and I can change one to the failure, and maybe the Bob. We change this to Bob, and when we run it, this is okay. This is the yes, we will run it, and it will show that some tests are failed, but they are not very helpful logging or some kind of error here, and we can have the 3V here. 3V we can have some call stacks of here, maybe with some variables, some owners, and we can have maybe the recover parts, the equal parts, kind of the actual or more detailed revert information here, and it will the left one is not equal to the right one, so the balance of the left one is the 1 and the 2, so we don't need to write some console log or some kind of others, so we have the actual information that we want to debug our smart contracts here. So kind of like I always use this 3V, or you can use the 5V if you like, but the 5V in some very complex smart contracts maybe there are too many outputs here, so I always use the 3V here. If we want to debug some specific call stack or the logics here, I will use more V's, and that's the favorite features that we love about the Foundry. Kind of like this, we can have the 4 tests, 4 V's, and we can match pace, and we can have the difference from the V's here. Okay. Different from the V's, yes. The 2V is logged for all tests, and the 3V is the execution traces for the failing tests, and one more is the setup traces for the failing, and the 5V is all the traces for all the tests here, and kind of like you can run with details, so you don't need to add actual debugging, some console log or some kind of other debugging information. You can get it from the tracing some logs here. And also you can have some building features about the test, and okay, I will reverse it to Alice. Kind of like this, we have some, if we run some tests and we want to, may run in the larger place. Kind of like the gas report here, we can have the gas report from each test, and make each smart contract here. We don't need to actually execute on some test chain or some kind of others. We can have the very beautiful the kind of the diagram or some table about maybe we deploy cost, and each function we have some the deploying size or some kind of average and kind of others. Yes, kind of information here. And there are more features that you can install, or kind of like you can install from some third-party libraries, because I think in this one we have kind of like in our smart contracts in the in the kind of the ERC one, we have the OpenZeppelin contracts installed here, but we don't need to specify maybe kind of the GitHub repo link. We can just use it in the remapping. Remapping, we have the, and we use the PNPM, kind of the NPM to install the, we use the kind of the PNPM install maybe as OpenZeppelin or some kind of other dependencies in our smart contracts, and we can remapping. And when we, if you are familiar with front end, when we run the PNPM install or kind of NPM install, it will be in the node modules, and it have some kind of the OpenZeppelin, and we have the contracts and the tokens, and the ERC20 is the one we want to use, is this one. And you don't need to specify all the kind of the relative maybe location of this file. You can use the remapping here, and when you use the OpenZeppelin, it will be in this kind of the directory, so we can directly use it in the kind of like here. Yeah, yes, we can just use it using the as OpenZeppelin. So it's and the Remix or the Foundry, they all accept this kind of format of the import here. And about the kind of like you can forge install, or you can install some other kind of the libraries here, and you can view the remappings, and you can update if there are some updating of these libraries, third-party libraries, and you can remove one, and for OpenZeppelin you can just using kind of the npm install, and you can configure it in the remapping part. And also you can have some very similar logics like console log. Console log is the kind of, we use it a lot in the Node.js or kind of the other TypeScript projects, but you can also input some the console also, and you can use the same method here. So if you want to check some, maybe if you are stuck with some debugging, and you can add more logs, so you can know where your maybe your error occurs, or kind of other debugging helpful functions, kind of this. And the two V's will show all the logs in the test, but if you are no V's, it will not show the logs here. Yes, and I think that's for the debugging, some install or some tests here. Also, the testing is kind of the trivial but very necessary things for our kind of the smart contract developers. We need to write as many tests as maybe we can, to ensure that before we deploy our smart contracts, we need to add more unit tests and more integration tests, or kind of more details or more edging case, so to ensure that we deploy the very final version of the smart contracts here. And I think it's for today's testing or some kind of that. Yes.
Yeah, so a lot of features, right? A lot of things to cover. It's very hard to cover in an hour, but if it's not clear up to this point, or if well, it's always good to have like a little summary of what we did today. So let me just clear everything here. Oops. Okay. If you want to revisit this, or if you want to not sure, or yeah, let me just zoom in a bit. The first thing you should check out is just this first steps with Foundry. This is like the init path for Foundry, of course. And just as a reminder of as a kind of a summary, we're gonna do this forge init, which is the command for initializing a project. So if we do forge init hello Foundry, it's gonna create a project named hello Foundry, a folder named hello Foundry inside this day8 folder. Yes, we can open up this one with hello Foundry, of course, with your editor of choice, and you're gonna see the project structure, the basic project structure for Foundry. As a reminder, we have the configuration file here in the root of the folder. We have a README, of course. We have a GitHub folder because this initializes a GitHub repo as well. We have the library folder for dependencies. Since Forge or Foundry installs dependencies like GitHub submodules, you're going to have also like a GitHub repo here inside, GitHub repos. One of these GitHub repos is Forge std, for example. But you can also install some more dependencies with the forge install command. And these are all going to be stored here in the library folder. You also have the scripts folder. We already see it with you, and this is just like a test script for the counter contract. You're going to have the counter contract here in the source folder. You can check that one out as well. Very simple contract. And you're going to have the test folder, which is going to have just a very simple test to cover up this counter functionality here. Set number, increment, and you can run these commands like it says in the guide. You can run forge build to compile your contracts here. Forge build, right? You can run forge test. After forge build, you can check your ABIs and your compiled contracts here in the out folder. This one is new. We didn't have this one before. You can test your contracts, forge test, and this will run all tests inside the test folder. And yeah, that's pretty much it for basic functionality of the Foundry. But I want to show you like how a real-world project or a big project can look like, just like you also showed with Foundry. So this is a real-world project, DeFi project. You can see that it has a lot of files, a lot of folders, but we keep the same structure, right? We keep the source folder with the contracts. Here the contracts are organized inside some folders as well. We have the scripts folder. Here we just have one script, which is the deploy script. And as you can see, it's like a very big script with variable initialization, some public variables, some external functions, and yes, so this is an example of a little more complex script. And you also have some dependencies here: Forge STD, Open Zeppelin contracts, Soulmate. One last thing, you have the tests as well. Same structure, but yes. I just wanted to show you how it can look like a big project. And if it's not clear why you have to use or why you should use Foundry, because you can just code your smart contract, of course, but you normally don't use just one smart contract for your project. You normally use like 5, 6 at least. So you want to have all your contracts in a structured project, and you also want to test all these contracts. You also want to deploy all these contracts in a nice ordered way. So this is why you use Foundry for smart contracts projects. And of course, this is going to do a lot of, it's going to be very helpful for the front-end team, for the integrations team, to read the smart contracts, to know what they have to use to connect to the smart contracts from the front end, from the APIs, and everything else. So very good, very nice, and it's very extensive as well. You should definitely check the Foundry book for this. You have every little command, every little configuration option that you want. So thanks. That's it for today. Thank you. Thank you. Any questions now?
I have a question not about Foundry, but your IDE, like what's the setup that you have that shows you the indents? You know, they're like highlighted. That's very helpful.
This highlight?
It's cursor.
You mean the code generation or?
No, I mean like